Before we talk about how to run regression analysis in SPSS, I want us to consider some of the issues that we need to take into account before we actually do our runs. And Allison points out that there are several things you need to check before you run your regression. Allison talks about the importance of cleaning your data. And this means double checking to ensure that the data is entered properly and that each piece of the data is a valid response category. It can be very easy to make mistakes when you're doing data entry, as your finger could slip on the keyboard, or you could just misread something, or you could skip an answer or go on to the next answer, and so on. Research methods classes probably talk more about how to ensure that your data is entered properly. One common system is to double enter the data, either by entering it twice or by having a second person enter that data. When I worked in a research lab in graduate school, we used a double entry system. And so each survey that came in was entered by two separate data entry workers. So maybe I would enter the data and I would mark that, that I had entered the survey, and then that would go into a stack and someone else would enter it a second time and mark it that it had been double entered. And then all we needed to do was to compare those two data files for that particular survey number, and we could immediately see if there was any differences in the way the data had been entered, and then we could go back and address it that way. So you can do that if you have multiple people who are doing data entry, but you can also do that with your own data. You can enter each piece a second time, and that way you can, and maybe you enter the same wrong thing, but most often, if there's an error in data entry, you'll find it through this double entry check method. Once you've entered your data, it's fairly common to run descriptive statistics on it as a way to check for improper responses or missing responses. By running frequency tables, you can see if there are any responses that are not coded properly. Maybe it's an answer, the number that's been entered doesn't make any sense for that data. For example, if you have a 1 to 5 scale, you strongly agree to strongly disagree, and there's a 7 in there. 1 to 5 are the only valid responses. 7 doesn't make any sense. So that would be, when you ran your frequencies, you would see that there's a 7 in your output as a response, and you can go back, find out which one has that 7, go back and check that survey and fix that error. You can also find if there are missing answers. So maybe you forgot to enter it, you double tabbed between questions and you skipped one. And so running frequencies lets you do, and this is a fairly crude way to clean your data, but it is one way, one sort of simple way, a quick and dirty, what you might call it, way to check to make sure that your data looks right at least in terms of meeting those criteria. Doing data cleaning, running descriptives, you're never going to know if you accidentally hit a 2 instead of a 3, if both 2 and 3 are valid responses. But this does give you a sense for those very strange responses where the answers are obviously problematic. Another issue is missing data. And there are times when people respond to only parts of the survey and leave questions blank. Maybe they're uncomfortable answering that question, or maybe they don't know the answer and they leave it blank. And we'd rather have them leave it blank and have missing data than have them make up an answer, which could be weird, or it could be wrong, or could bias our result in some way. So we have to decide before we begin to analyze the data how we're going to deal with missing data. So when we're entering it, we choose a category or response designation for missing data. We talked earlier in the semester about how commonly 8 and 9 or 98 and 99 are included as missing data categories, and those can get pulled out from running the analysis. But when we say pulled out, we have to think about what that means. When we're creating our data file, we have to tell SPSS which response categories are going to be identified as missing, 98, 99, 8 or 9, what have you. We also have to decide how we're going to deal with that when we run our analysis. There are 2 standard ways to deal with it. One is to remove that entire case from analysis, meaning that any person who didn't answer the question that you're running analysis on is removed from that analysis. And so none of their answers to any of the other questions will be part of your output because they are removed entirely from that statistical run. This is called list-wise deletion or complete case analysis. So that removes that particular case from the analysis and it reduces the number of cases included in the study. So if we ask a question about income, this is one of those questions that people don't like to answer. And so maybe 17 people left that question blank. Well, when you run a regression with income being your dependent variable and education being your independent variable, for example, those 17 people that did not report their income, that skipped that question, would not be included in the analysis. So the total sample size would be reduced by 17. And what that would actually mean is that everybody who didn't answer the income question would be excluded completely, and anyone who didn't answer the education question would be excluded completely. And so you end up running your statistics on a smaller number of cases where you have complete data. The other common method is pairwise deletion. And this is also known as available case analysis with pairwise deletion. And what happens here is that the missing value is placed with the mean value for that variable. So if we're talking about education, for example, and you have a couple of people who did not answer the question, then the computer would replace that education variable with the average education of everyone who did answer the question. So if the average education was 13 years, then 13 would get put into those missing values. Now you can see how this could be problematic because it assumes that the missing data doesn't vary from the other data in the data set. And that's a scary assumption to make. And actually, Allison doesn't recommend using this method at all, but it is one that you often see. Allison suggests a third alternative, but what he suggests isn't widely available in statistical packages. I actually looked for this in SPSS the other day and I couldn't find it. Doesn't mean it isn't there, just means I couldn't find it. He suggests using the maximum likelihood and multiple imputation system if it's available. But if it's not available, again, he suggests the list-wise deletion method, where you just completely remove that case out of the analysis if there's a missing question. And it's just a missing question for that particular run. So if they answered all the other questions, then if you run a different set of statistics with different variables, they would be included that time. They just get excluded whenever there's a missing value. Allison also talks about how to create dummy variables for your nominal level variables. And he does this by using the recode tool that I shared in the bonus tutorial. And for each response, you recode into a new variable with the response category equaling 1 and then everything else equaling 0. And so what I have on the left here is the original variable and how it's coded. 1 is never married, 2 currently married, 3 divorced or separated, 4 widowed. The SPSS for syntax here, you recode MARSTAT, which is marital status. So if they are currently married, you now make that 1, and everything else you code as 0 into a new variable, currently married, CURMAR. Okay, so what he's doing in this is he's taking each category of the original variable and he's giving that a 1 and 0 dummy coding and creating a new variable for it. So instead of having marital status, we now have 3 variables related to marital status: currently married or not, divorced or not, and widowed or not. Remember that when you're doing this, you leave that reference category uncoded. In this case, the reference category is never married. So he didn't do a recode for never married. because that's going to be our reference category against which everything else is compared. So it would be this compared to ever married. Okay, so that's the one that gets left out. We talked earlier about how some variables are not linear, but they're curvilinear. And these variables sometimes require recoding by using squared or cubed terms in order to address the curvilinear nature of the function. You may also want to use logarithms on some variables that have large variations, such as income. Age is one that you often see logged as well. And using a logarithmic scale squishes down the variation in the model in that variable, making it easier to graph so that you don't have this very broad graph, but you have a squished graph. And if you don't understand the logic of logarithms, which I can tell you I still struggle with myself, we will talk a little bit about logarithms and log logistic regression and log linear regression next week, and just sort of introduce what we do when we don't have these linear models or we have some non-standard data, okay? And we use logistic regression when we have nominal level dependent variables. So we have a way of explaining and running analysis on that, and then we'll talk about how we interpret that. So we'll talk about those things next week.